So we have the initialization of tables in distance vector routing. So we have this particular network with us, A, B, C, D and E, and these are the various tables that will be initially placed with the values. Since the machines can directly talk with the neighbors, so we can easily have this information. But we have to move forward, because if we take A, from A we cannot reach E because the cost is infinite. Because it is not directly connected, right? So this A needs to have this information from maybe B or C in order to reach E, because they have a direct link from their own machine to E. All right. So as we move forward in distance vector routing, each node shares its routing table with its immediate neighbors periodically and when there is a change. So it is a very simple routing mechanism that we have. So one particular instance is when this routing information will be shared is periodically. Okay, with time they may be exchanged, or else if there is a particular change. Okay, so if there is a link failure or maybe a new node is connected, right, those informations can be immediately shared with your neighbors. Okay. So now updating is distance vector routing. So we had this particular scenario where A had a table, okay, and now C is providing its own information to A. Okay, so let's see what information C had. What information C had was, see, these are always in an increasing order, so they are always alphabetically placed. So we will only remember this 2, 4, 0, infinity and 4. So 2, 4, 0, infinity and 4. Okay, so this particular value from C is provided to A. So A's table is going to get modified. Now it is a very simple modification that has to be made by A, because as soon as this table reaches A is also going to see what is the distance from A to C. The distance from A to C is this particular row. It is 2, right? Because A keeps the destinations in the first column. So if you look at C, the cost associated to reach C is 2. So it is 2. And after that, whatever value has been provided from C to A, okay, will have this column increase with 2. Because see, if A has to depend upon this table that is provided by C, then it must first go to C. That means this 2 has to be added to all the cost here in order to reach these particular values. Okay, what I mean by this is, suppose we take E here. So in order to go from E to C, the cost is 4. Okay, but if A has it now, okay, if A has this row information now, in order for A to go to E, it has to first go to C, that is 2 here, plus this 4, that is this 4 here. Okay, I repeat once again. If packet has to go from C to E, then the distance is 4 and the information is provided here which goes to A. Now if A wants to go to E, it has to just add a plus 2 here in order to have it in its own routing information table, right? So in order for A to reach A from A to E, it has to update its table from infinity to 2 plus 4. Okay, because earlier it was infinity. Why? Because A did not have knowledge about the path to E. However, when it received this particular information from C, it knew that from C it takes 4, suppose the cost 4, so it is only going to add this cost 2 here with 4 in order to have a complete information. Okay, so similarly for all the other destinations, it is going to add a 2 here, because if it has to reach all these particular destinations, it has to first go to C. Okay, so a 2 has to be added to all of them. Okay, so this will become 4, 6, then 2, then infinity remains infinity, because from C also from C you cannot reach D according to this particular table, because C does not know about D, because D is not a neighbor, right? So what A is going to do is, it is going to blindly add plus 2 in all these values. So it is 4, then 6, then 2, then infinity and 6. So is the value correct? Let's see. 4, 6, 2, infinity 6, 4, 6, 2, infinity 6. So it is correct. Okay, So after A has received this information from C, it has added a +2 in all the cost values. Okay, it is not going to add anything in infinity, because you can also take it like infinity +2 remains infinity, right? So this particular row will remain unupdated. However, the next hop are going to change. Why? Because the information that was provided from C forces A to first go to C, then go to the destinations, right? So the next hop has to be C placed in the last column, right? This is obvious, right? Because if A has to rely upon the information from C, or the routing table from C, then it first has to go to C in order to use this particular table, and that's why the next hop values that you see are C as well. Okay, for all the records it is going to be C. But at the same time, there was an initial table that A already had. This is 0523 infinity, 0523 infinity. Okay, so a comparison has to be made now. And what is the comparison? A has to keep the minimum value out of these two records that it has, because if you have to reach the destination, you should always try to find the minimum path available in order to have proper optimization, right? So though A has taken the information from C and has updated according to its own convenience, however, another matching has to be done with the earlier record as well, because who knows, A might had a better record than the new one, right? It may happen, right, that the previous record was better than the new one, and it happens in this case. For instance, if you look at this particular table, A, in order to reach A, is going to have a cost of 4 now. Okay, if we depend upon the information from C, then the path is 4 now. Why? Because if A depends upon this table to reach A, it has to first go to C, then go back to A. So it will be 2 plus 2, which is 4, which is not optimized, right? So A can keep the earlier record, which was, if A has to go to A, then there is no cost associated with it, because it is the machine itself, right? So what we do here is we try to take the minimum value out of this respective two values. So 4 and 0, the minimum is 0, we keep 0 here, and the next hop associated with it, which is nothing. Then 6 and 5, the minimum value is 5, so we keep 5 here, and next hop is nothing. Then 2 and 2, so both are same, so let's take this one, because if we don't have to go to any hop, then it is better than going to a hop, right? So it is this. Then if we take infinity and 3, see, now we have a minimum value, because A already had the information of D, right? Because if you look at this particular network, A already had the information of D, C did not have it, so it was infinity. But in case of A, it already has it, so A is going to take the minimum value, which is 3, and 3 is here, and the next hop is none, so we keep none here. And then we have 6 and infinity here. And now earlier A did not have information about the path to E, however C has provided it, and it is 6, because C is lesser than, of course, infinity. So we have 6 here, and we keep the next hop that is associated with it, and this is how we get the updated routing table of A. Okay, so then we will go to 2-node instability and 3-node instability in the next video. Thank you.